Hello, and welcome to Kennedy Space Center in Florida. I'm NASA's Megan Cruz, and you are watching the pre-launch news conference for NOAA's GOES-U satellite, which is targeted for launch on a SpaceX Falcon Heavy rocket tomorrow, June 25th, from KSC's Launch Complex 39A. The 2-hour launch window opens at 5:16 p.m. Eastern Time, and NASA's Launch Services Program is managing launch. Now, GOES-U is the fourth and final satellite in the National Oceanic and Atmospheric Administration's Geostationary Operational Environmental Satellites R series. These satellites provide continuous watch over the Western Hemisphere, helping scientists and forecasters to issue timely warnings and forecasts. And GOES-U will also improve the detection and monitoring of space weather hazards using a new compact coronagraph instrument. Now, the mission team just completed its launch readiness review, so to share the latest mission updates, we have Steve Volz, the Assistant Administrator, NOAA's Satellite and Information Service. Next to him, Pam Sullivan, Director, GOES-R Program at NOAA. John Gagosian, Director, Joint Agency Satellite Division. And next to him, Dr. Denton Gibson, Launch Director, Launch Services Program here at NASA. Julianna Scheiman, Director, NASA Science Missions over at SpaceX, and the man in the hot seat, Brian Cizek, Launch Weather Officer, 45th Weather Squadron at the U.S. Space Force. Now, each will give some opening remarks, and then we'll take some questions from those in the room here. All you have to do is just raise your hand. For those on the phone, you can get into the question queue by dialing *1. So without further ado, let's turn it over to Steve.
Thank you, Megan, and good evening, everyone. As you just said, we're just 24 hours away from the launch of NOAA's GOES-U satellite, the last and the best of the 4 satellites in this GOES-R series. When we were here in 2016 to launch GOES-R, the first satellite in the series, it ushered in a new and transformative era of advanced Earth monitoring technologies to ever orbit in space. Our National Weather Service colleagues tell us that this technology has since changed the game for weather prediction and forecasting. GOES-U is making history of its own. It carries with it the world's first ever operational satellite coronagraph, called CCOR-1 for compact coronagraph, that will significantly improve NOAA's ability to monitor the sun and forecast potentially harmful space weather events such as coronal mass ejections, which we saw a few weeks ago, a big one in the U.S. in the country. But probably the most important reason GOES-U is historic is because it is the bridge that connects today's geostationary satellite technology with the technology of tomorrow that promises to provide an even more sophisticated and more impactful than what the GOES-U satellite series currently provides. If you can bring up the slide, please. We're working with Congress right now to support the continued development of the Geostationary Extended Observations, or GeoX, GeoXO satellite system that will be ready to continue the GOES mission without interruption into the future. GeoXO will feature a suite of instrumentation that provides continuity to the GOES mission and introduces novel new measurements in sounding and ocean color and atmospheric analyses. Pam Sullivan will be giving you more details on some of these. GOES-U is a NOAA mission, but it is accomplished through partnerships. As with all our GOES missions, NASA has played an essential role in bringing this satellite to the launch pad and to orbit. The NOAA-NASA partnership has successfully launched many environmental satellites into orbit over the past 50 years for geostationary observations. And NOAA relies on our partnership with industry, who build our instruments and our spacecraft, who provide launch vehicles, and who help us process, manage, and interpret our data. GOES truly is a national mission. The launch of the GOES-U underscores NOAA's commitment to putting the best technology in space to monitor weather, water, and climate, and the sun, and with unparalleled accuracy and timeliness. And with that, I'd like to turn it over to Pam Sullivan, and thank you, and go GOES-U. Over to you, Pam.
Thank you, Steve. Hi, I'm Pam Sullivan. I'm the program manager for NOAA's geostationary satellites. So NOAA's geostationary satellites are an indispensable tool for protecting the United States and the 1 billion people who live and work in the Americas. They provide a constant real-time view of weather and dangerous environmental phenomena across the Western Hemisphere. GOES-U is the fourth and final satellite in the GOES-R series, which is NOAA's current generation observing system. If we could bring up the graphic, please. Since 2016, the GOES-R satellites have brought amazing new technology to help forecasters better monitor hazardous weather conditions like hurricanes, thunderstorms, floods, and fires. The main camera on the GOES-R series scans the Earth disk every 10 minutes and can zoom in to track dangerous conditions as often as every 30 seconds. The satellites also include a lightning camera, which takes pictures of the Earth 500 times per second to track lightning to help identify severe storms likely to spawn tornadoes, hail, and damaging winds. GOES-U was developed by a team of people from NOAA, NASA, industry, and academia. It continues the decades-long NOAA-NASA partnership to get the best technology into space for accurate, up-to-the-minute forecasts and for long-term climate monitoring. Our primary industry partners for GOES are Lockheed Martin, which developed the spacecraft and the Lightning Mapper instrument, and L3Harris, which built the Advanced Baseline Imager, as well as our operational ground system. GOES-U also carries 5 instruments that help monitor space weather conditions. They are a particle flux sensor built by Assurance Technology Corporation, a solar irradiance monitor from the University of Colorado, a solar imager from Lockheed, and a magnetometer developed by NASA's Goddard Space Flight Center. The new compact coronagraph instrument on GOES-U was developed by the Naval Research Lab. GOES-U will be launched on a Falcon Heavy launch vehicle built by SpaceX. GOES-U is part of a multi-generation family that began with the first geostationary weather satellite in 1975, and it will continue operations into the 2030s. To ensure that these critical observations continue after that, NOAA is now developing its 6th generation geostationary observing system called GeoXO. GeoXO will have advanced instruments that provide an order of magnitude more data. These include an imager with improved spatial resolution for more precise tracking of fires and storms, an ocean color sensor to monitor water quality and hazards, and atmospheric sensors to track air pollution and improved numerical weather modeling. GeoXO capabilities will help us address the challenges of a changing planet, from more unpredictable weather to more prevalent harmful algal blooms to more widespread wildfires. As we prepare for the launch of the final GOES-R satellite tomorrow, we are already working hard to have the first GeoXO satellite ready for launch in 2032 in order to ensure the continuity of these critical observations. Next, I'll pass it on to John Gagosian.
Okay, thank you, Pam. And I am John Gagosian, Director of NASA's Joint Agency Satellite Division. Our division is part of NASA's Science Mission Directorate, and we manage, on NOAA's behalf, the development and deployment of operational weather satellites like GOES-U. Our 5-decade partnership with NOAA has resulted in the successful operation of more than 60 satellites dedicated to weather forecasting, severe storm and hurricane prediction, and climate observations. We are very excited to complete the 4-satellite GOES-R series with the most capable geostationary weather satellite in our nation's history. NASA is responsible for the formulation, development, launch, and initial operation of the GOES-U satellite. Our team has incorporated many lessons learned from the previous 3 satellites in the GOES-R program. Consequently, GOES-U has a very well-proven design, in addition to the exciting new capability represented by the compact chronograph. Our joint NOAA-NASA team has been working diligently with our industry partners to be fully ready for our launch tomorrow. We're also delighted to continue the NOAA-NASA partnership into the future as we move through the design phase of GeoXO, the system of geostationary satellites that will deploy in the 2030s, and which was described by Steve and Pam earlier. I'm proud that NOAA and NASA have collaborated so well over the life of the GOES-R program, and that we are poised for a very strong finish. And now I'll turn it over to Denton Gibson.
Hi, I'm Denton Gibson. I'll be the launch director, the NASA launch director for this GOES-U mission. And I can say I'm excited and humbled to be here in front of you today, working with this team in front of us. This team has done a lot of hard work to get us to this point. And I just want to take a minute to recognize the world-class organizations, NASA, NOAA, SpaceX, and U.S. Space Force Space Launch Delta 45. It's done a lot of work to get us to this point, and happy to be here. This will be NASA LSP's 9th mission with SpaceX. 2nd on the Falcon Heavy, and this will be SpaceX's 10th Falcon Heavy, as a matter of fact. We'll be taking off right here from 39A, which is a very historic launch pad. It is very iconic vehicles have launched from this, Falcon being the 3rd of that, which was, of course, it launched the space shuttle as well as the Saturn V, so very historic. And about a week ago, we started our preparations for getting the launch team ready and prepared by doing a mission dress rehearsal where we put our team through the ringer. I mean, we really exercise the team, making sure the team is ready through a simulated launch countdown, really making sure our team is ready for this mission. And then about last Thursday, we had our flight readiness review, which went well, where all organizations came in and agreed that we were good to continue with launch processing. And also on Thursday, the GOES-U spacecraft was mated to the Falcon Heavy. And shortly, actually in progress right now, is the Falcon Heavy has left the hangar at 39A and is on its way up to the pad deck. Now I have a video to show you some of the hard work that this team has done. Can you please play the video? All right, so here you're looking at the GOES-U spacecraft arriving here back in January. And here it's transporting from the landing skip, and it's heading to the payload processing facility in Astrotech. There's a shot of the GOES-U spacecraft all bagged. And they're just showing you some of the processing and the lift operations. And here it's being mated to the payload adapter, which happened a few weeks ago. And you can see the mate operation going on there. And then you see the next day, the spacecraft being encapsulated into the Falcon Heavy payload fairings. And you can see it's completely encapsulated, and then there's transport on its way to hangar at 39A. And here is some representative shots. This is from the Psyche mission. There's some representative shots what the role actually looks like, and what is actually taking place right now. And then that's what it'll be looking like vertical on pad. And here's a live shot of the roll from the pad. It's looking like it's right about to get to the pad deck, and hopefully we'll be going vertical in sometime tonight. Yep. All right. So this morning we had the Space Launch Delta 45 launch readiness review, and earlier this afternoon we had the joint NASA SpaceX launch readiness review, where the leadership of Space Launch Delta, NASA, NOAA, and SpaceX all agreed to continue and go into launch count tomorrow. You know, it's only fitting that weather's going to be a factor for this weather satellite, right? And I'm sure you hear a lot about that coming up here shortly. But weather permitting, the launch team will arrive on console tomorrow afternoon and perform the final vehicle checkouts. And then tomorrow, about an hour before our targeted T0, you'll hear the team get the final go to load propellants onto the vehicle. And after completing the propellant loading and adequate checkouts, that launch vehicle and spacecraft will be ready for our targeted T0 at 5:16 p.m. Eastern Time tomorrow. So just to summarize, the GOES-U spacecraft is ready, launch vehicle is ready, and we are looking forward to getting this spacecraft on orbit to get some groundbreaking space weather, because you know it's very important to us folks living here in Florida, whereas weather can get spicy at times. So looking forward to this. So with that, I'd like to turn it over to my colleague, Julianna Scheiman.
Thank you, Denton. First, I'd like to start by thanking NASA and NOAA for their support ahead of tomorrow's mission. It's an honor to be here today with all of you. Every time I come here, I talk about how excited I am for the mission, and this mission is no different. GOES-U is a game changer for weather forecasters and climate researchers alike. But what's the coolest is when you turn on the news or you open your weather app, that data from these GOES satellites is what's going into that forecast. And so we at SpaceX are incredibly proud to support such an important mission that has an impact on all of our everyday lives. Now for some stats. To reiterate what Denton said, this will be our 9th launch for the NASA Launch Services Program, and it will be our 10th Falcon Heavy launch. It will also be our 65th mission of the year, this year. After liftoff, the 2 side boosters for Falcon Heavy will return to land. So if you're in the greater Cape Canaveral area, make sure to listen for those sonic booms. As you heard the team mention, the GOES spacecraft operates more than 35,000 kilometers above the surface of the Earth in an orbit called geostationary orbit. This is an incredibly high energy orbit that necessitates an incredibly powerful rocket to get there. And it's this orbit that drives the extended payload deploy. So payload deploy for this mission will be 4.5 hours after liftoff. One of the other unique things about this mission is we partnered very closely with NASA and with Lockheed to leverage Falcon Heavy's performance, so much so that this launch of GOES-U will be the most performance launch. We'll have the most performance a GOES spacecraft has seen on orbit. And what that means is the spacecraft can preserve propellant and extend its overall mission lifetime. So that's something we worked in coordination with NASA and Lockheed, and something we're really proud to enable for the GOES team. This is one of 2 Falcon Heavy missions we actually have this year. So we have GOES coming up tomorrow, and then we have Europa Clipper in October. And Europa Clipper will help us understand if there is a habitable world in our solar system. So I look forward to that mission and this mission as well. But for GOES, things are looking really great. Some of the team may be aware, we were originally tracking to roll out the vehicle last night, but instead the vehicle, as you saw from the live feed, is actively being rolled out right now. The reason for that is when we, first of all, we roll out when we're ready, when it's safe and reliable, and we have all the systems we need to do so. And one of the systems that we need during rollout is an environmental control system, a transport air conditioning system, because the spacecraft, when it's in the encapsulated assembly, needs to maintain its contamination, its humidity. We need to protect it before we put it safely in space. And so one of the things that's really important is to have that transport air conditioning unit with all of the redundancy it needs for rollout. So during preparations for rollout last night, we discovered that essentially the system has redundant parallel systems in it, and one of those legs of that system was not operating. So we decided to keep the vehicle safe, keep the spacecraft safe in the hangar, make sure that that transport AC unit was fully functional, and now you can see we're rolling out that transport AC unit is fully functional and providing very cold air to that GOES spacecraft. So things are looking really great on the rocket. As you heard from Denton, we're on track, and I'm going to pass it over to the man of the hour, Brian Cizek, to tell us more about the weather.
Thanks, Julianna. And I admit I kind of feel the weight of the weather world on my shoulders a little bit with this launch, with it being a weather satellite and a satellite that myself and my colleagues will look at on a daily basis, especially here in Florida. And speaking of Florida, we are in our, we're in late June. We are now in our summer wet season here in Florida, where we get kind of our daily thunderstorms firing up each afternoon as we get heating from the surface. And speaking of that, I figured, why don't we show a live image right now of the current GOES East satellite. So this is the satellite that GOES-U is eventually going to be replacing. I think that this does a good example of showing kind of a typical Florida summertime pattern here. So if you notice on both coasts there, we can see the sea breeze front pushing inland. Notice near Cape Canaveral Kennedy Space Center, we see the sea breeze pushing inland where it's clearing out behind it. That's behind the sea breeze, and you can see out ahead of it, that's where we're seeing some of the cumulus clouds, showers, and even some thunderstorms firing up. So that's really the driver of our weather here in Florida in the summertime. The land heats up a lot faster than the ocean does. That triggers the sea breeze to form and push inland, and that sea breeze actually acts as like a little mini cold front that can trigger showers and storms along it. So these are what we're looking at. You can see some of the storms to the north. You can see the thunderstorm that develop, and then we see the anvil clouds. So those are those kind of high wispy clouds that form off the top of thunderstorms when they hit the top of the troposphere, and then they travel with the upper level winds. So that's something that we will have to watch tomorrow as well, because those anvil clouds can actually carry a charge from the thunderstorm that could be potentially dangerous to fly through or near. So speaking of the forecast tomorrow, I do expect conditions to be a little bit different than what we saw today. There's a cold front that's digging into the southeastern U.S. That's going to increase moisture in our area as well, and also shift winds a little bit southwesterly, a little bit more offshore than we're seeing today before the sea breeze kicks in and shifts winds more southeasterly. So that tends to focus the sea breeze and the associated showers and storms a little bit closer to the east coast when we get southwesterly flow, because it pins that sea breeze a little bit closer to the coastline there. So for tomorrow, we're going to go with a 70% probability of violation or a 30% chance of go for all the weather rules that we evaluate. So we evaluate a set of 10 lightning launch commit criteria that are designed to protect not just against natural lightning, but rocket triggered lightning. A rocket can actually trigger its own lightning strike if it flies through or near a cloud that could hold a charge, and it can increase the electric field in the atmosphere by up to 100 times. So that's what these rules are designed to protect against. So the ones I'm highlighting here, the cumulus cloud rule, several anvil cloud rules. So we have an attached and detached anvil rule. So that's what I mentioned, those high clouds that come off the top of the thunderstorms. With westerly flow tomorrow, I think the storms will be able to push a little bit inland. The southwest flow is fairly light, so the sea breeze should be able to develop and push inland, but the upper level flow is westerly, so that will try to bring some of the anvil back towards the launch pad. So the sweet spot, I think, tomorrow, if we can find that window, and with the 2-hour launch window, I think we'll have a decent chance here to find some sort of window in here where the sweet spot would be when the storms push a little bit inland, but before we see kind of anvil development off that and before they're able to push back towards the coast. And then in the event that we use the backup day, pretty similar conditions. Again, we have some offshore flow, very moist air in place, moderate instability, I would say. So again, another good chance to see some of those afternoon and evening thunderstorms that we will have to dodge for the backup day as well. But we'll have a full launch weather team on console tomorrow. We have a team of launch weather officers and forecasters, and we'll be monitoring things very closely in communication with the launch team. And if we can find a window, we'll take it. That's all I have.
Thank you, Brian. I know we're giving you a little bit of a hard time, but we obviously know how serious you guys' work is, and we thank you for what you guys do to make sure that we can launch this rocket safe. Okay, so we appreciate those opening remarks, everyone. It's now time to take some questions. So again, if you're here in the room, raise your hand and wait for a microphone to get to you. Remember to ask one question and direct your question to someone here, and then if you're on the phone, star 1 to get into the question queue. Okay, right over here.
Hi, I'm Jim Siegel. I'm from Florida Media Now. Let's see, I think this is a question for Steve. You mentioned that you're working with Congress on some aspect of this, and I wonder if you could elaborate a little bit more. Just what are you working on with them? Are you looking for more funding for additional technology or a second round of goes or what?
Thanks for the question. And yes, we're working all of our satellites. These are national satellites. NOAA as an agency is funded by appropriations from Congress. And we work with the Congress every time when we're developing and establishing a new mission. As we said, the GOES-U is the 4th of a series of satellites we initiated in the early 2000s, and it's the last. So we're done with this series in terms of building. It will still operate for another 10 to 15 years, but we've built them all, and tomorrow, hopefully, we'll see the launch of the 4th one. To ensure continuity, and these measurements, those observations you just saw on the screen show a calm day, and we want to make sure we get those kind of observations continuously, even during every day. We're building right now the next generation of satellites, which we call GeoXO, the Geostationary Extended Observations. That requires a new commitment of funding and appropriations from the Congress to make that happen. We started this about 5 years ago in the late teens, talking about the geostationary, the extended observations, and we have worked with Congress, with the administration, with the Office of Management and Budget, all of the stakeholders on how to quantify that program. And Pam Sullivan's been the key lead on this in establishing that, sort of defining the parameters of that mission and telling them what the cost of that mission will be for the next 30 years. We build satellites, we build systems that last a generation. So the GeoXO constellation, the first will launch in 32, the last will launch probably in the early 40s, and they'll be operating well into the 2050s. So we're talking about a 30-year program, which costs on the order of $20 billion, but amortized over 30 years, a long time. So we don't do that on a turn of a dime. It takes a little bit of time and effort, and we have worked with all participants in Congress who understand the importance of weather observations and the criticality. And so we have good support. This current fiscal year has authorized the appropriations to continue the development of these missions, as Pam may speak to it later. All of our instruments are under contract except for one, which we're still in the process of finishing. Spacecraft is under contract, so we're well on the way in the initiation of that next generation of GeoXO, with good support from Congress because of the importance of our mission.
Is any of that $20 billion already allocated allocated, approved?
Yes, Pam, how much of that is already, we've been doing this for several years. Pam, you want to take that, how much has already been allocated and appropriated?
Over the last 4 years, almost $500 million has been appropriated.
All right. Thank you for that question. Right over here.
Hi, Ken Kramer, Space Up Close. Thanks for doing this. A lot of great information. For SpaceX, yeah, thanks for explaining the delay. I think we were all wondering about that. So the other thing I'm wondering about is the Falcon Heavy. Why a Falcon Heavy was chosen for this? It seems a little overpowered. You explained a little bit that you can save some propellant because you can deliver it to a better orbit. Can you quantify that and go into some more detail, please? How many more years, how many pounds of propellant are saved, and what does that translate into years of service, if you can? Thanks.
Yeah, sure. I'm happy to help and happy to be transparent about what's going on. I think the way we think about defining the orbit injection requirements from a launch vehicle perspective for a mission that's on its way to geostationary orbit is in terms of delta V to geo, basically delta V meters per second remaining to get to that geostationary orbit. So when the spacecraft team came looking for a launch vehicle, they were looking for a launch vehicle that could provide 987 meters per second to geo. And because we wanted to make sure that we were providing the best solution for NASA, we ended up now providing on the order of 566 meters per second to geo. So smaller number, less energy required for the spacecraft to get to that orbit, which enables them to save that propellant. I am not an expert on the spacecraft. I'm an expert on the launch vehicle. But my understanding is it's on the order of years of operational life we're saving for the spacecraft, which is something we're really proud to help support. And so I would say it's just right sized for that.
Yeah. Let me just add to that. The number of years, our normal spacecraft specification lifetime is 15 years. With the added capability that the Falcon Heavy is giving us, we expect to be 20 plus years of life, fuel life. Yep.
Great.
Hi, everybody. Thank you for doing this. Meredith Garfalo, Space.com, Rocket Girl Enterprise. I'm happy to be with you guys today. A couple questions. First one is for you, Brian. For tomorrow, how many forecast updates are we looking at? And for people at home, what can we expect with that process? And then my other question is, I think for SpaceX, what can we look at as far as before the clock hits zero? Obviously, the refueling is different than with the Atlas 5 rocket that we saw before. So how does it go? I think, if you could explain a little bit about that process with the fueling and then with the window and how that coincides.
Sure. So I'll start. So typically, our final forecast product that we post would be on L-1 day. So the one out today would be the final one that you would see on the website. However, and the reason for that is on day of launch, we get it on console and we're communicating with the launch team for tomorrow. So, one of the first things I'll do, I'll look over all the forecast data, and then my first touch base with the range coordinator or the launch director, I'll give a POV, a probability of violation update. Additionally, tomorrow with the PA team, with the live coverage, I'll make sure to be in communication with the PA team, with Megan over at NASA to make sure they're up to date as well with the latest forecast, the latest probability of violation. We'll also have a couple representatives from the 45th Weather Squadron out here at the press site, so they will be available to help answer some questions about what the latest is with the weather.
Yeah, and to speak to the Falcon Heavy launch operations, so we'll work very closely with the NASA Launch Service Program team and the spacecraft team to make sure that we're all well coordinated on launch day. One of the important milestones that happens in the count is when we load the cryo-cooled propellants on the vehicle. With a 2-hour window for goes, we'll work closely with Denton as the launch director for NASA to decide when it makes sense for us to load that propellant. Once we load that propellant, we are working with a fixed T0. We don't have the ability to move that launch time. So with that 2-hour window, we'll be talking to Brian, we'll be talking to Denton, we'll be figuring out when we want to most optimally pick that launch time, and then we load propellant about an hour before launch. So that'll be a joint conversation, trying to find that gap in the clouds.
Okay. I know that there are some questions in the room, but let's go to the phone really quick. This is Sawyer Rosenstein from NASA Spaceflight.
Hi. Thank you for taking my question here. I really appreciate it. On I was wondering if you could talk about any of the struggles that you may have had in terms of integrating a payload that's normally integrated vertically, this time horizontally, and also just really quickly if you can specify which booster is PY and PX. Thanks.
Sure. So, first of all, we are really proud to be launching this GOES-U spacecraft, and we have worked really closely with the Lockheed team, with the NASA team, to make sure that from tip to tail we have a really great integration plan that we've executed successfully so far. One of the unique things that we've done to support the GOES spacecraft is enabled what we call interleave telemetry, where the spacecraft's basically the spacecraft telemetry, the spacecraft health data on launch, on ascent, will be actually transmitting from the SpaceX, from the Falcon transmitters. It's a unique, an example of a unique modification we've made to support the GOES mission. On the SpaceX side, as far as horizontal integration is concerned, we do this integration operation the same way we do any other one of those horizontal integration operations. No change to our standard ops. And I think there was another question about the boosters.
Yeah, which one's PY and PX, basically? Which is which?
You mean like from a serial number perspective, or?
Yeah, which one's which side, essentially, from serial number wise?
I can follow up with you offline. I think one of the things that's interesting to note about the GOES mission that's different from other missions is we're flying new boosters for GOES. And at times we do that. Basically, one of the things that we have with reusability, right? We're reusing our vehicles, but we also need to replenish the fleet. And a decision we made in coordination with the NASA Launch Services Program was it makes sense for us to replenish the fleet now with these new boosters. So the two side boosters that we're launching, those will come back and we'll reuse them on a future mission. The center core will be expended and we will not reuse it on a future mission.
Yeah, and I just want to add to the part about working with a spacecraft that was normally vertically integrated and was integrated horizontally. So part of in the Launch Services Program, what we do is we work with the spacecrafts, understand their requirements, and work with SpaceX to come up with the plan of how can we integrate them into the launch vehicle. And that's something our team has worked. Because we have that familiarity with SpaceX, we have familiarity with the spacecraft, it's something we work years out. And we lay out a plan. Sometimes, as Julianna had mentioned, there's some mission uniques that we work through to ensure that we can integrate this spacecraft to this launch vehicle. And that's work that we do for each one of the LSP missions that we work. So that's a standard part of what our team does, is ensuring that the spacecraft can be integrated into the launch vehicle, whether it's vertically or horizontally.
Great, thank you both. Reminder to those on the phone, *1 to get into the question queue. But let's head back into the room here. Will, you had a question?
Yeah, Will Robinson-Smith with Spaceflight Now. Question for Julianna. You mentioned this is the 10th Falcon Heavy launch and that the center core will be expended. Given what you've learned on the Falcon Heavy vehicle to this point, are there plans down the road to be able to reuse that center core, or is it sort of just standard operating procedure moving forward? Just it makes the most sense to expend that center core. Thanks.
Yes, thank you for the question and the opportunity to explain, because I actually get this question a lot. So when you think about booster reusability, whether we're landing a booster on land or whether we're landing a booster downrange on a drone ship or whether we're expending a booster, all that choice has everything to do with how much performance the customer requires. So some missions require less performance, in which case we can preserve some of that propellant to return that vehicle to land. And in some cases, we need to provide more performance to our customer. So for Falcon Heavy, we can do a lot of different permutations, as you can imagine, with 3 cores. For example, for GOES-U, the 2 side boosters are coming back to land, the center core is expended. That was the performance point that made the most sense to meet what the spacecraft needed, to meet the spacecraft requirements. For Europa Clipper, as an example, coming up for NASA, that will be a fully expendable Falcon Heavy. Turns out Europa, the moon of Jupiter, is pretty far away. And so it kind of gives you a sense of matching the performance by the rocket with what the spacecraft customer needs.
Any more in the room here? Go ahead.
Space.com. This question is for Brian. I don't know if you have the data, but with the other 3 GOES, how has it been with the percentage being low like this that we actually launched on time? Is there hope, with the weather, that we could still I know you mentioned that it's going to be that sweet spot, but historically, how have we done with that?
So historically, what we aim for is to try to match our probabilities that we forecast for with kind of like the probabilities that it actually occurs. So, a perfectly reliable forecast would be if we have a 30% probability of go, 30% of the launches tend to happen on time. So I don't have the exact numbers off the top of my head, but we've been pretty good over the last maybe 10 to 20 years if we look at our data set, that it's pretty reliable in the sense that our forecasted probabilities are fairly close to what is actually observed.
Okay, over here.
Question for Brian to follow up. Ken Kramer, Space Up Close. Sometimes you, when you make these forecasts for SpaceX especially, you have a range of probabilities from the beginning to the end. Sometimes they get better, sometimes they get worse. I wonder if you have that for this launch.
That's a good question, and we do that because oftentimes with the Starlink launches, we might have a 4-hour launch window, and there could be a big difference from the start of the window versus the end of the window, or even sometimes it's in the middle of the window. That might look the best or the worst. So if we see a pretty strong trend, we do try to reflect that in our launch forecast. For tomorrow, as of right now, it's kind of hard to determine where exactly in the window that's going to be. I think there's a higher chance to see more cumulus cloud with the showers and thunderstorms early in the window potentially, depending on how far inland they get, whereas towards the end of the window might be more of an anvil concern because I expect the showers and storms to be further inland, but there'll be more time for those upper level clouds to work their way back towards the coast. So it's one of those things. I think tomorrow we're going to have to see how the thunderstorms and showers play out, how far inland the sea breeze gets, and we'll have a better idea when we get on console as we go through the countdown. I think that's when we'll be able to hone in on when the best time in the window is.
Will you be able to inform us after NASA starts their TV broadcast of what it looks like?
Sure. So we'll do our best to relay on our forecasted probability of violation to the PA folks. As I mentioned, we'll have a few launch weather officers out here at the press site, and they'll see some of our latest communications. So we'll certainly do our best to get the latest forecasted probabilities out.
And Ken, we'll pass those on during the launch broadcast as well. As he said, we'll be in contact. All right, Jim, go ahead.
Hi, Jim Siegel again from Florida Media Now. A question for Pam. You mentioned about lightning, and some people say that Florida is the lightning capital of the United States, if not the world. And I'm interested in before a comparison of before the GOES process against now we have 4 GOES satellites. What's different in terms of how well or how differently you communicate about lightning then versus now?
This is the first time the U.S. has had an operational geostationary lightning mapper with the GLM series. And forecasters, it took a while, I think, for them to kind of realize what it could do. But the main thing that I hear from forecasters is they have more confidence in a forecast right now. If they see a storm, there's a lot of lightning, they can say that's really going to be severe. I'm really going to issue that warning. They have more confidence in doing that and defining where that warning, geographically applies to when they put that out. But we're also learning things about lightning as a phenomena. With GLM, we've actually seen the world record long lightning strike of 477 miles. Nobody had any idea, I don't think, that they could be that long. And that one touched ground like 100 different times along its path. So, the other this is other interesting phenomena we're seeing with the lightning mapper is sometimes fires have enough smoke that they've got enough updraft that they actually form clouds, and those clouds can have lightning. So sometimes the fires can, create some lightning that continues them. And so there's interesting things like that now that we've got that constant view up there, we're really seeing some interesting phenomena that's improving our understanding of weather systems, as well as being the day-to-day, help that the forecaster needs and that confidence.
Good answer. Thank you.
Thank you.
If you don't mind, I'll just add in here as somebody who forecasts lightning here in Florida quite often, I can tell you it's been very helpful having GLM, being able to see the lightning, and also forecasting the onset of lightning before it occurs. The more rapid scan rates that we get from GOES, we can see those storms as they're starting to grow. And that can be really helpful here in Florida, where we get rapid convection. So you could get a cell go from almost nothing to a thunderstorm in a very short amount of time. So having a more rapid scan rate where we can see the cloud as it's growing is very helpful to forecast the onset of lightning before it even occurs.
And one other point, it's just a great example, as Pam was mentioning, about fires creating its own lightning in some cases. When you look at a phenomenon with a whole different perspective, like looking at lightning while you're looking at imagery for storms and things, you see connections that were never available or never visible before. So bringing together different observations of the same phenomenon reveals new understanding of it. And that's what one of the things GeoXO is going to be doing by bringing not just lightning mapper and high-resolution imagery, but hyperspectral sounding and ocean color observations and atmospheric composition observations, looking at all those with many different viewpoints of the same phenomenon. You see connections and interdependencies that were not available before, which gives you a much better understanding of the complexity of the phenomenon and your ability to forecast it as well.
And since we're talking about capabilities, I'm seeing a lot of chatter online. We at NASA invite people to be a part of the conversation by using the hashtag #AskNASA. So there's actually a question from social media right now. How far from space can the GOES-U identify a fire-based event, and why is that important when fighting wildfires? Pam, did you want to start that? Or?
Yeah, sure. Well, the main camera on GOES-U, like GOES-R, it'll be looking at the entire Western Hemisphere once every 10 minutes, the entire U.S. every 5 minutes, and again, it's zooming in and doing what we call smaller mesoscale areas as frequently as every 30 seconds. So it really can see a fire within minutes of when it starts. From the start of a fire, you can. That information is really in the local officials' hands to deal with. So.
And one other thing we've also added, working with actual supplemental funding we got from Congress for this, is it's not just taking the observation, but using the observation. So working with the Weather Service, with the Forestry Service, and with local emergency managers, have integrated those GOES data directly into the whole pipeline of the value for application. So there's a fire weather test bed web application that's developed by NESDIS that's working with the Weather Service, which makes you can drop down and see fires occurring and initiating across the United States or by region and see when something occurs in near real time. So it's available, the information is immediately available to responders in the communities so that they can actually go out, and often it turns out GOES is the first indication you have a fire, even before the local community might call it in, because we see it from space before it's been indicated by the locals around there. So the first call an emergency responder might get is from the Weather Service saying, our geostationary satellite spotted a fire over the horizon in this little county location. Maybe you better go look at it. So it's getting that whole pipeline together, not just the observation, but all the utilization into the hands of people who need to respond. Because we just alert the fire, we don't actually respond to it. It takes that whole community.
Yeah, an incredible tool. Will, you have a question here?
Yes, Will Robinson Smith, Spaceflight Now again. Question for, I think, Steve and or Pam. In being able to track this data from the years that the various GOES satellites have been on orbit, can you describe how, sort of in totality, that's allowing you and your teams to create better climate models and have a better frame of mind for climate change impacts? And, if that helps to tie into the pitch to Congress and lawmakers in, moving forward with the GeoXO. Thanks.
Do you want to start?
Sure.
You start, I'll finish.
Okay. Good. Yeah, so having that long history since the 70s is really used to monitor climate change. There's different kinds of parameters that are evidence that the climate is changing. You know, a warmer planet is a cloudier planet, and so the cloud record that we have over those 50 years shows that increase of cloud cover. Also with GLM, a warmer planet has more lightning as well, so that's another climate variable that's going to be tracked with the series. And the satellites themselves are looking at sea surface temperature, land temperature, so it's seeing that direct measurement of temperature as well as these, you know, the phenomena that are affected by it. And of course the, you know, the incredibly intensifying hurricanes that we've seen recently that really get fed by that, that warm, you know, tropical water, and the fact that, you know, storms can go, you know, increased by 100 miles per hour in a 24-hour period. You know, that is something that never happened before. And so that's, again, something that's tracked and, you know, a reason that you really need to be watching these storms in real time to see that intensification when it happens.
I have very little to add, but I will comment that, as Pam said, that climatology of 50 years of the geostationary is not easy to do either. Recently, we worked with Pam's science team to collect data from GOES 1 through GOES 18 to make all those data sets interoperable and interconnected, because they're different instruments, different generations, different calibrations. You can't just put them all together and get a continuous data stream. But the science team, working with our partners in Europe as elsewhere, have managed to make a continuous climatology of clouds, of radiance from the planet, and these things do change slowly over time, but you can actually see that with that long-term climatology. And as the point made earlier about the temperature of the land and the water, similar land climatologies and water temperatures, you see those connections and you see those interdependencies, which do feed into, as you suggested, climate models, both as a verification of the models themselves, but as a more detailed indication of where we're going and what trajectory we're taking. So often the comment is weather data is, who cares about yesterday's weather? We obviously care about yesterday's and last decades and 50 years ago, because it gives us a better climatological look at what's going on the planet.
And just looking forward, I'd say, you know, when we went out to our user community for GeoXO and said, you know, what do you think you're going to need in the 2030s and 2040s? They said, I'm seeing climate change. I'm seeing more fires. I'm seeing stronger hurricanes. I'm seeing harmful algal blooms in places that they never happened before. And so our user community really said, you know, you need to help us with these tools so that we can monitor these things that are happening because of the warmer planet.
Is that message translated to Congress as well? Yeah.
With a lot of people, yes. So, yeah.
Yes, and yes and no. I would say yes for certain audiences, but the precision of our measurements are driven not just by the need for a long-term data record, but our models, our numerical weather models and the like, require that high precision observations. You have to know the temperature of the atmosphere to a half a Kelvin absolute temperature around the planet to start your model. That requires extremely precise instrumentation. So that requirement alone drives the instrumentation we fly, but it also supports the climate use of these data sets, because these are accurate and precise going through the lifetime of the mission and into the future.
All right, we have time for one more question.
Yeah, I think a lot of broadcast meteorologists, that's my background, would like to know what are the weather parameters when we talk about violation, when we're explaining this to the public? I know we talked about cloud anvils and lightning. Is there a certain mile range, anything more specific? We could kind of break it all down, what you're looking for.
So I mentioned the lightning launch commit criteria. So we have a resource on our website. If you go to the 45th Weather Squadron website, there's a good kind of infographic there. But we're monitoring a set of 10 different rules that we look at to look at the risk for both natural and rocket trigger lighting. So there's different types of clouds that we know could have the potential to hold a charge that could be dangerous to launch through or near. So for example, with cumulus clouds, that's more so like the core of a thunderstorm. Or, you know, just on the daily basis, you could see out in Florida those kind of puffy cotton ball looking clouds. Those start kind of small and then they grow taller and taller, eventually into thunderstorms. So the taller they get, the more likely they are to hold a charge. So the taller they get, the farther the standoff distance are. The anvils, we look at those as those could carry a charge. We look at clouds that might break off of a thunderstorm that could carry the charge with it as well. We look at some layered clouds, stratiform type of clouds, and if those are thick enough, that would violate another rule called the thick cloud layers rule if it's in a certain level of the atmosphere. So generally, that mixed phase layer of the atmosphere is where you can get a charge, so maybe about the freezing level up to about the minus 20 Celsius level. So that's kind of where we would see, if you get clouds in that region of the atmosphere, that would potentially hold a charge depending on what type of cloud it is. So generally speaking, it's about a 10 nautical mile ring around the launch pad and the flight path where we'd start to be concerned, and then there's some different standoffs as well as you get inside of that. But generally speaking, about 10 nautical miles is the standoff where we start to get concerned. Yeah.
Very appropriate to end this news conference with a weather question. All right, so that brings us to the end of this news conference. Thank you so much who participated and really added to the conversation about GOES-U, as well as the launch operations that are going to get us to T0. Again, tomorrow's 2-hour launch window opens at 5:16 p.m. Eastern Time. Live coverage will begin on NASA TV, NASA Plus, and the agency's social media channels at 4:15 p.m. Eastern Time. You can see the information there on the bottom of your screen. Also, for mission updates before and after that live coverage, you can scan this QR code that we're going to bring up on your screen right now. It'll take you to the website, blogs.nasa.gov/goes. Again, that QR code you can scan for mission updates. Thanks for joining us today, and go GOES-U.